Welcome to Mathematics with Tom. I am Tom, and today we're going to write a system of differential equations as the matrix equation and a linear combination. So here we go. Let's start with the matrix equation. So the matrix equation is going to come from the original system of differential equations. So let's write this. This is really, on the left-hand side, we're going to write this as a vector, y1 prime, y2 prime. So there's my vector on the left-hand side. And this equals, now notice that my coefficients, or what you could think of your weightings, your weights, as the y1 and y2. For example, we have 4 y1s and plus 1 y2 in the first system. Or you could think of this as we have the vector 4, 3 that has a weight of y1. Well, that just gives me the matrix of 4, 3. That's my first vector. My second vector is 1, 2. And then my weights, my vector of coefficients, is the vector y1, y2. Now that might seem strange because now y1, y2, yes, they are weights, but they're also functions of t. I know these are differential equations here. So I'm going to also put in the 1 that came from right there. There's the 1, the 2. There's my second column vector. So that is the system of differential equations that we're going to solve. Now here's what gets even more interesting. Down here on the left, well, we're going to write this matrix equation. I'm going to remove some of my title there. It also can be written as this vector of y1, y2. We're going to just call it the vector of capital Y equals the matrix 4, 3, 1, 2. Oops, I'm sorry, capital Y prime times, and then this is the vector of y, so we'll just call this capital Y. So you might also see it written like this. Now, let's come down here. So down here, I have the vector y1, y2. So now we're writing the solution as a linear combination. We're writing the solution as a linear combination. So I'm just going to break this up. My first vector is going to be this c1 e to the t and a minus 3 c1 e to the t. So we're going to make that a vector, plus the second component is, or the second vector is c2 e to the 5t and c2 e 5t. But we can do better than that, because for the vectors need to just be in the bare bones minimum. In other words, in this first column vector, c1 and e to the t, that's just a scalar. That's just scalar multiplication. So I'm going to write the first vector as the scalar c1 e to the t times the vector of 1 minus 3. Plus my greatest common factor in the second vector, the scalar, would be c2 e to the 5t. And then my vector then is 1, 1. Okay, that is how we write a system of differential equations as the matrix equation. We have that up here above, and we write the solution as a linear combination. All right, and in our next video, we're going to see how we can check our results. I hope that helps, and thanks for watching.